Hello, in this video we will discuss the electronic voltmeter in a practical way. The first part of the electronic voltmeter, which is the voltage modifier, will be removed from this circuit because this circuit is designed to measure voltages that are domestic. So, if we want to measure higher voltages, we will use the voltage modifier and it will work as the following. The reason behind using the voltage modifier is to use the same voltmeter for measuring wider range of voltages, and it will work in the following way. When the voltage that we want to measure is applied at this point, the selector disk will select a proper branch that contain a reliable resistor, and that resistor will modify the voltage in a proper way. As the voltage is applied here, a current will pass through this branch, and there will be a voltage drop in this resistor. So, the voltage after modification will be reliable to be measured by our voltmeter. Current in this branch is equal to the potential difference between this point and this point divided by the value of the resistor. By the simplification of the equation, we get the applied voltage after modification will be equal to the applied voltage or the voltage that we want to measure minus the voltage drop in the resistor. After the voltage modification, it will pass to this time dependent switch, and that switch will open and close automatically depending on a time interval which is set in it previously. When this switch is closed, it will pass the signal to the comparator circuit, and when it's opened, there will be no signal to the comparator circuit. During its closure, the capacitor in the comparator circuit will begin to charge, and during its opening, the capacitor will begin to discharge. The second part of the electronic voltmeter is the comparator circuit. The daily used electronic voltmeter contain operational amplifiers as a comparator circuit, but I used NPN transistor to show variety in the design. The circuit is composed from the following parts. The first one is NPN transistor, which is general purpose NPN transistor. The function of the transistor here is to act like a switch that will oppose the passage of pulses from the pulse generator depending on the time of its opening. The base of the transistor is represented by this wire, and this wire will bind in this point with two things. The first one is the positive end of the voltage that we want to measure, and the other thing is the capacitor circuit. The capacitor circuit is composed from 1000 microfarad capacitance and a resistor with 100 ohm resistance bind in series with each other. The other end of the resistor will bind in this point, and to increase the capacitance we will add another same capacitor in parallel with the first one, and that will double the time constant of charging and discharging. The collector circuit of the transistor is represented by a unijunctional diode. The negative end of the diode will bind in this point, and the positive one will bind in this point. The function of the diode is to prevent the backflow of current in the reverse direction when the transistor is closed. The emitter circuit of the transistor is represented by this large resistor, and this is 10k ohm resistor. The first end is bound to this point, which is the emitter of the transistor, and the other one is bound to this point. The third part of the voltmeter is the oscillator circuit. There is a large number of oscillators, but I used this type because I saw it suitable. It's composed from two NPN transistors that are similar to each other, two capacitors, and a variety of resistors. The positive end of the power that make it work is applied at this wire, and the negative one is applied here. The oscillations can be taken either from this end or from this end. The comparator circuit and the oscillator circuits will bind in the following manner. The positive end of the battery source that makes the oscillator work will bind in this point. The positive end of the oscillator will bind in this point with the emitter circuit. The negative terminal of the oscillator will bind directly with the negative terminal of the battery. The oscillations can be taken either from this point or from this point. The action of the transistor here is to act like a switch that prevents the passage of power from the battery source to the oscillator, and it will be opened for a certain period of time. The time of opening of the transistor is directly proportional to the voltage that we want to measure. As that time increases, the number of oscillations from the oscillator will increase. Now let's see what happens when we want to measure 3 volts. We will apply the positive end of that voltage in this point and the negative one in this point. We'll count for 30 seconds, then remove the battery source. As you see, the circuit is working by the power held in the capacitor. As you see, it needed 57 seconds to stop. Now, we'll do the same thing with this 6 volts battery. As you see, the circuit starts to work. We'll count for 30 seconds and remove the battery. Now the battery is removed and the circuit is working by the power held in the capacitor. As you see, it needed 1 minute and 30 seconds to stop. So, as the voltage that we want to measure increase, the time of the closure of the switch will increase. So, the number of pulses will increase.